So over the weekend, I was really looking at this question of calculating volume and developing a surface for uh, this area about this pond. And put this video together because an engineer thought that it was really interesting. He didn't know that you could do this with a GIS, and so I just wanted to lay out the procedure here in hopes of sharing it with others so that we could kind of understand how you can go about addressing this question. Um, so for this particular area, this is a surface pond. There's what needs to be done in this area is it needs to be capped. There's some constraints here, and that we want the cap to have no more than a 3% slope over the entire area. So the question is, how do we go about calculating or really estimating a volume for this area? So the first thing we do is locate some aerial imagery just to sort of get our bearings. We purchased this imagery for this site last year sometime. Next, digital elevation model is it's a data set that's available from the USGS. Essentially, it's just you can read about what these things are, but they're used all the time in GIS to model the surface of the Earth in different areas. This is a 1/9 arc-second digital elevation model that basically equates to cell sizes of about 3 meters. So I'm taking time here to explain this because it's everything else that after this is really predicated on understanding what this thing is. It's just a raster data set that has these pixel values right here, the actual elevation. You can see everything in this pond area is 2.48 meters, and then up on these bermed areas you can see it's about 4 to 4.5 meters. So we have the general area we're interested in. We know that we want a 3% slope. From that, we can calculate everything else that we need in order to get at this volume estimation. So the second step to do, like I said, or really the first step, we obtain the DEM. I've just color coded it here to so that you can distinguish the colors better. We then have some subsetting masks. We know that the cap for which we want to calculate volume is really just within this pond area, so we've created a couple of masks here. And then since we already have this digital elevation model, I figured we'd go ahead and just make some contours for it. So just going to zoom out here a second. You can see that here's a previous sort of landfill area, and the digital elevation model has actually captured that. Okay, so we put the contours in just to sort of get at what our base contour level is for this thing. And basically, we want our cap to sort of start here. At least in this scenario, the cap's going to start at this minimal contour area. The contour has been created in feet, and so that's that. And so from that, we really have kind of everything we need to create this distance grid. So basically, inside of the GIS, we calculate the distance from our base contour line towards the center of this area. We're going to need this distance variable in order to count in a percent slope calculation in order to get what the vertical distance is here. So then what we do is we then simply make that calculation, and what it all that is our distance grid. We multiply that times 3%. We then add that to our digital elevation model. What that gives us are the elevations in this area that range from 2.48 meters down here on the edges up to 4.14 meters. So this, if we're going to constrain this shape, this area to a 3% slope, the highest elevation that we can have in there based on our calculation is about 4.14 meters. So what we can do now, we can use the difference between this newly calculated surface that we have in here in the area, and use that. We know the difference here. This is our base digital elevation model. This is our hypothesized surface after that. And from that, we simply perform a canned sort of cut and fill volume calculation for this. And here's the volume. It is negative, and the reason it's negative has to do with the order in which you stack the layers before you do the calculation. So you can see that we have 22,671 cubic meters over an area of about 33,000 square meters. That comes out to about 29,650 cubic yards over an 8.34 acre area. Okay, and so we did all this stuff, we created all this data, and inside of ArcGIS, or actually ArcScene, we can do some kind of fun video gamey type visualizations for this, where we actually drape the image over our digital elevation model. And what we can do is begin to sort of visualize these things. So what we have here is the image drape over this DEM. Here's our OAP area. It's the graininess of the image is due to the resolution of the DEM. Remember, we have a fine grain image that we're draping over a much more coarse digital elevation model, so the image quality sort of is what it is. I think we've kind of got our bearings here, so I'm going to go ahead and turn this on to get a better idea of what's going on. So there's things we can do. We can for visualization type stuff, we can take and we can drape the our contour lines over this just to kind of begin to have maybe a better understanding of the surface in three-dimensional space. And we can also pop in our surface, our new hypothetical cap surface. It's not that impressive. There's not a whole bunch of topographic relief here, but we can exaggerate that probably more than is actually warranted. But to sort of, you can begin to see, oh, okay, kind of get an idea of what's going on here. So the visualization part of this is just, at this point, maybe it's helpful, maybe it's not, but I think it does kind of begin to help us to really appreciate and understand what you can do with GIS data aside from simply making a map. We're able to get some real world, metrics out of it with our volume calculation, and take those calculated surfaces and begin to look at how we can use these to incorporate in any subsequent reporting. So that's kind of all I had. I hope it's helpful. Thanks.